All right, so here we're going to talk about our vocabulary for section 3.3. The first word that we're going to look at here is graph. Now, many of you are going to already know what a graph is, right? So the definition being is really a picture of information from a data table shows the relationship between variables. So what this is really talking about is really a graph, is a graphic or a picture of the information we have in a data table. And we've used data tables, we record information, and it shows the relationship between variables. So let me show you what that means. So if we look at an example here, so a line graph displays data that show how one variable, so our responding variable, changes in response to another variable, the manipulated. So we talked about these earlier in the school year. So we have our responding variable. Now remember, that's what's reacting or changing in response to our manipulated variable, and that's the thing that we're deliberately changing. So we want to see how these are related, and we can see that over on our graph here, where we have the age in years of something. In this case, it's going to be small town teens with cell phones. So we're looking at how many teenagers have cell phones, and so we're looking at how their age of years, so if we're changing our age in years, how that affects the number of teens that actually have those cell phones. So here we're looking at the number of cell phones. We're seeing how that changes in response to how old they are. So we have our age in years. That's basically what we're changing, and we're seeing how that relates to that response of the number of cell phones. And so then we have a graph, and we have that plotted, and that's really all a graph is. Now a graph, it could be a line graph, which is what our example is and what our image here is showing. It could be a bar graph, really. It could be any sort of graph. It's just a pictorial or picture, a representation of the data that we collected. And they can be really helpful because they'll show us things that sometimes aren't immediately apparent in our data table. If you have a lot of data, especially, you may see the numbers and think, okay, I think this may be what's going on. But it's really hard to actually say, okay, yes, this is the type of trend that we're seeing. So we make a graph, and then we can clearly see differences. I mean, with this, we see that in general, as age goes up, the number of teens with cell phones increases, but then for whatever reason, the age 18, it drops, then it goes up, and we can ask, okay, well, what the heck's going on here? It went against what we kind of were seeing, and we can start asking those questions. So it can kind of help us take another step in our analysis of our data. Okay, so then moving on to our next word, we have a linear graph. So we just talked about what a graph was, and so now we want to be more specific and say, okay, we're looking at a linear graph. So now really this hint here being line. You can kind of see if you just take off that AR, we have lines. So really a line graph, or really what it is a line graph in which the data points from form a straight line. So we have a line, right? So that helps us in knowing that we have a line, but not all lines are straight, right? We could have a curved line, a bent line, all these different things. And so in this case, it's going to be a straight line, and that's what's going to be a linear graph. It's a straight line. So a linear graph allows you to find trends, make predictions, and find anomalous data. And so with that, right, so that's kind of an example of why we would use a linear graph. And so our picture here is we have distance and we have time, just a very standard graph. And so we're seeing as, we go travel for the distance, how does time go? And we have this linear graph. So we're moving at kind of a constant rate, right? If we were to find the slope, it would be the same everywhere on this graph. And so really, when you're looking at a linear graph, it has to have that straight line. Now this next one is a non-linear graph, and just by the name you can kind of figure out, well, okay, that's not going to be a straight line because we have that non, meaning not, right, not linear, non-linear in a graph. So it's a type of line graph, so a line graph in which the data points do not fall along a straight line. So a non-linear graph has no linear relationship between the variables, but has a form of relationship, and so that's really key. And so right here, again, this is another kind of example of what it could look like, really. It still has a form of relationship. It's not just random peppering of dots, right? If we could have dots all over the place, there's a form of relationship. And so in this case, we have a form that's kind of curved. And so we have the time of years and the length of something, right? So you have an example of a curve, and we have, these things right here. We have our title. That doesn't really tell us what we're looking at. So we have time of years and some sort of a length. And so as that time goes on, it increases fairly rapidly, and then it kind of levels out. And so that's what we get with a non-linear graph. We get kind of a bent or a curved line where there's some sort of trend, some sort of relationship between these variables, and it's predictable in the sense that, all these dots are following this line, and we have an idea of where at, 2.5 years where we'll be, but it's not that perfectly straight line that we see when we have a linear graph. So kind of touching, we talked about anomalous data, or sometimes I refer to them as an outlier. We talked about them in our last section of 3.2, and now looking, okay, well, how does this look like on a graph? And graphs are really easy, or really a good tool, make it really easy to determine if you have data that doesn't seem to belong. And so here, we know we have an anomalous data point. If the point falls away from our straight line, it is considered to be an anomaly, as it does not fit most of our data. So if we have this, and you'll notice none of these are necessarily exactly fitting on here. This red line is something that we refer to as a trend line, in which it is kind of like the average in the sense where it finds that middle point between all of our points of data. And so it gives us a general idea of, okay, for the most part, all of our points, if we were to predict them, are going to fall around this line. Whereas this one here that's circled, it's pretty obvious that, well, that one's a lot further from the line than all these other points. It's got a pretty big distance. That may not quite belong. Something's going on with this data point that it doesn't seem to fit the rest of our data. The rest of these, well, maybe not exactly on this line, they're really close. And so that way, this line of best fit, this trend line, tells us, okay, if we had to draw a straight line for a graph, it would, this would be best to represent all of our data. Most of our data would fit on this line. That's what this is, this trend line. In this case, this one, it doesn't really fit at all. So if we just kind of ignore this, we get a better line. Whereas if we have this, it can cause our line to kind of creep up here a little bit, and then it doesn't really fit any of our data real well. But if we just have one data point that's way off, we'd say, okay, well, odds are something happened with this data point, and since it's the only one, we can say it doesn't represent our trend. So something, some variable we didn't control during this one had an effect. So now we can just kind of exclude it and have our trend line here. And so that's kind of what we have, or how we can show an anomalous data point, and really how we can kind of treat it. And that just about sums up our video on vocabulary section 3.3 for our science and technology unit. If you have questions on any of these words, please let me know in class. Thanks.